I'll give you guys the answers and then the multiple choice answer, and then once we hear all the answers, I'll have you guys just shout out what you think is the right one, and we'll talk about it. Sound good? All right. So, number one, what is a conductor? A factory installed group of wires, any material that allows the flow of electric current, the guy riding in the back of the train, rubber, plastic, or dry wood. Any material that allows the flow of current. What is conductor insulation for? The answers are to protect the conductor from other conductors, to protect the conductor from damage, to keep the conductor warm, or A and B. A and B, yes sir. Yep. What good is a cable sheath? A place to keep a conductor when you're not using it, a group to group conductors together, environmental protection, extra environmental protection, or B and C. B and C, yep. What does AWG stand for? Always wire the gray, any works good, American Wire Guide, or American Wire Gauge? Gauge, yep. Got a couple of people with that one. American Wire Gauge. What is the gray building wire commonly used for? We went over this 15 minutes before we took the test. Current carrying conductor, ground conductor, or neutral conductor? Yeah, I had 5 people not remember that from when we talked about it 10 minutes before the test. Okay, what is the purple or pink building wire commonly used for? Current carrying conductor, neutral conductor, ground conductor, or switch leg? Switch leg, yep. Had 5 of us not get that. What would you use a bare conductor for? Grounding, neutral, current carrying, or to keep the cows in? Grounding, right. What color sheath is for 14 AWG non-metallic sheath cable or Romex? Orange, black, white, or yellow? 14. White, yep. 6 of you didn't get that. What color is 10 AWG Romex? White or yellow? Orange. You didn't get that. How many total wires are in 12-3 Romex? 3, 4, 5, or 1? 4. Yep. There he is. What is KC mil an abbreviation for? Known circumference measured in a line. That was a pretty good one I made up. Circular mills, American wire gauge, keep calm, mama's looking. Also another fun one I made up. The answer is circular mills. KC mil is an abbreviation for circular mills. I got 9 of us hooked on known circumference measured in line. Pulled that one out of a hat. Name one advantage of solid wire. It's flexible, it's easy to terminate, it's available in all wire sizes. Everybody got that one. Easy to terminate. Way to go. One advantage to stranded wire. It's flexible, easy to terminate, or available in limited wire sizes. It is flexible. Everybody got that one. One advantage of copper conductor. It's light and easy to work with. Nope. It's a great conductor. Yup. Cost less? Nope. Has a higher resistance than aluminum? No. It's a better conductor. That's the advantage. What's the advantage of aluminum conductor? It's light and easy to work with, lower resistance than copper, has no oxidation problems, is more expensive than copper. It's light and easy to work with. Almost everybody got that one. What is white building wire commonly used for? And that one is also what? Neutral. Yep. Everybody got that one. Now we talked about this one in class. What do you do with the white wire in a 14-2 Romex that you are using as a switch leg? Who remembers? Not everybody. Your choices are cut it off, tie it to the bare conductor, permanently mark it black, Land both wires on the same switch. On the same screw on the same switch. Permanently mark it black. Yep. Yep. Remember, because you're changing it from being a neutral to a current carrying conductor by moving it through the switch. That's why you have to permanently mark it black. Yes, sir. Okay, everybody clear on that one? We had only 33% of us actually got that one right. So, where wouldn't you want to use underground feeder? And I believe this one is the one that I think I gave to you guys because where wouldn't you want to use? Yep, that's what I wanted to say. Inside metal framework, that's where you wouldn't want to use it. Underground is where you would, and a service is where you would, and not in a raceway is where you wouldn't. Or no, excuse me, UF cable's not for a service. So I think I just gave you guys this one for my fault. So how many wires are in 12-2 UF cable? 2, 3, 1, or 4? 3. 3 is the answer. What is the maximum voltage rating for thermoplastic cable? 24 volts, 120 volts, 300 volts, or 50 volts? 50. Yep. Thermoplastic cable is commonly used for what? Heating and air conditioning controls, chimes, garage door openers and controls, fire alarm controls if properly rated, or all of the above? All of the above. Yes, sir. Where is armored cable generally used? Residential applications, industrial applications, commercial applications, or main feeder applications? The correct answer for that is commercial applications. What must be installed under the connector of an AC cable? Electrical tape, the red bushing, the bonding conductor, B and C. Yep. Yep, I caught a couple of people with just the red bushing there, but we also got to rotate that bonding conductor back through. What does metal clad cable have that AC cable does not? Bare bonding wire, green grounding wire, red wire, metal sheath. Man, I hooked some of you guys with metal sheath. Come on, guys. That's clearly in your book there. Just read it. Where is service entrance cable SE typically used? Commercial applications, residential applications, industrial applications, or in a raceway? Residential applications. Yep. What is special about the SE cable sheath? Flame retardant, abrasion resistant, armored exterior. There's nothing special about it. Flame retardant. Yep. Where would you most likely install underground service entrance cable? I caught somebody with multi-wire branch circuit. Overhead service drop, industrial plants, or underground services. You mean to tell me you use underground service entrance cable for an underground service? Oh my goodness. Come on, guys. Come on. Read the question here. You are most likely to encounter service drop cable, overhead triplex, also multi-wire branch circuits, got 2 people. Overhead service drop was the right answer. Industrial plants or underground services. I'm glad I didn't see anybody with underground services. I might have just quit. Holy smokes. Service drop for underground service. No, sir. Where is mineral insulated cable commonly used for? Service drop conductors. Somebody got that one. Hazardous locations. 21 of us got that. Heating and cooling controls or motor wiring. I got one for heating and cooling controls and one for motor wiring. Okay. Here's one we talked about in class. Where are you most likely to work with a flexible cord? Pulling wire in a raceway? Nope. Feeding a detached garage? Nope. Hooking up a new dryer? Yup. Or an underground service? Nope, we're not going to use a flexible cord there either. How many separate conductors are in 12-3 SO cord? 3. 3 conductors. Not 2, not 4, not 1. 3. Give me 2 examples of communications cable. Coaxial and thermoplastic? Nope. AC and MC? Nope. Fiber optic and Cat5? Yup. Romex and UF cable? Nope. Almost everybody got that one. Somebody didn't even venture a guess. What is the advantage to having bundled cable? You can run each communication conductor individually? Nope. It eliminates the need to run each cable separately? Yup. It's simple to find one pair of conductors? Nope. Easy to fix if the cable gets cut? Heavens no. You ever seen them poor guys that got to go through them big fiber bundles? Oh my goodness. Oh my goodness, those poor fellas. Okay, we specifically talked about this one before we started taking the test too, and I still had a lot of people get it wrong. What is the minimum voltage you would want to use medium voltage cable on? 1,000 volts, 1,500 volts, 480 volts, or 2,000 volts? The correct answer is 2,000. Okay, when using aluminum conductors, what is required when terminating? Proper torque on the lug, oxide inhibitor, a robot from the future. I'm pretty happy nobody picked that one. A and B. The answer is A and B, and that was choice D. Proper torque on the lug, an oxide inhibitor. So the correct answer was A and B. All right, everybody remember why I added that? Why I put that in there and been talking about it? Because in the 2017 code, it is required to have your lugs on your terminating lugs properly torqued. Each one's different, and it's even different depending on your conductor. Yeah. Okay, what can you use easily pulled through a raceway? Bigger guys pulling. Well, yeah, you could do that. A rope instead of a fish tape, that always helps. Less wires for sure helps. But the correct answer that I was looking for in that one was wire loop, and everybody got that. So, what do you guys think about this test? I feel like it was a pretty fair test of stuff in the book and stuff we talked about. Only real problem was that question 18 that I just gave you guys for attempting. But we had some people that did super, and we had some people that did not so super. And this is pretty easy basic stuff that I took the test directly almost entirely out of the book. So, and that's going to be the way that we're moving forward too. So those of us that didn't do so well may need to remember to spend a little extra time in our book when we move forward. Okay. So if there's no more questions about the old testaroonie, we can start moving into non-metallic boxes. Everybody get out your code books also, please. Slideshow. Okay. Okay. Anybody's blue Ford got their lights on? You got a green Ford. Okay. From current slide. Okay, gentlemen. Yeah. Yeah. Okay. So here we are again.
What chapter do we need to get to in our code book? I asked you guys to read through the introduction because there may or may not be a question about that on the test.
So let me get a drink of water before my throat goes out. I kind of want to pick up before where we left off when we were talking at the end of class last week with device boxes. We'll just blast through here, but the most important thing I want to do is for us to go to Article 314. There's lots and lots of good stuff there. It's a pretty long article, and I want us to spend a little more time in it than we did the other day. So the first part I want to touch base on is device boxes. Let's find in the code where it talks about device boxes. If there's a nice handy spot, let me see if I can also pull up my code book too. Does it have anything in there just specifically for device boxes? .16. Yep. Number of conductors in the outlet. We're going to spend time with. We're not going to hit it too hard right now because that will be in part of your code class next semester. 314.3, non-metallic boxes. Yep, that's definitely where we're headed. That's what we want to know for sure about today is non-metallic boxes. That's where we're definitely going to spend our time today, and we're not going to worry about 314.4 metal boxes. Okay. I would like to direct your attention to number of conductors in outlet boxes, device boxes, and junction boxes. This is a pretty important one for us to remember because this has to deal with our little cubic inch mark that's stamped inside of each one of our box for us to be able to figure out how much actual wires we can put inside each box. And if we continue on down the line here, there's a chart here for our metal box size. That's going to be pretty standard for the metal boxes. We're not going to kill that too much right now. We'll talk about that next. But what I'm trying to get at with the size is that each one of these is going to be marked with the size of the amount of wires that you can put in here. And if we look at table 314.16b, that's how much each wire is going to take up in square inches inside of our box. So let's talk about some 14. This particular box right here has an internal cubic inch volume of 32 inches. So how many number 14s can we stick in this box? 2 divided by 32. 16. That's kind of the long and short I wanted to take away from this, is that each wire has a certain amount of cubic inch that it's going to use. Was it yours? You're such a dork. All right. Each one of these boxes has a cubic inch mark on it, and that's what's going to prevent or allow us to put the amount of wires that we need into each box. And that's going to go into when you start to figure out your layout for your electrical circuits inside of your lab out here. You're definitely going to have to start paying attention to that, especially when you start talking about switches. If your switches are going to be very complicated and you have several 3-ways or some 4-ways in there, that's something that can definitely be a factor to you. So, all right, let's get back to the slideshow here. kind of my goal is for us to be able to finish this up today. I want to assign, we'll talk about some homework stuff that I want you guys to look at, and then have a test on next week. Okay. So moving into here, device boxes, throwing up gang box signs. What is a gang? What's a gang? Yeah, you like that? Funny joke for you? Okay, good.
Gang box signs.
What's a gang? Who can answer?
Right, that's what they are, but what is the gang even about? Absolutely. It's where how many devices you can put in each box.
So that's what your gang is. It's the amount of devices that you can put in each one of these boxes. Okay? And then we have the different types. We have right here the nail on, which is clearly shown to us with the nails. Everybody, nails equals nail on. Got it? Okay. We have a screw in box in here. No, I don't think we did. No. Next, screw in box. What do those equal? Screw in boxes. If you see screws on the inside of a box, it means a screw in box. I'll show you a picture in a minute. Side bracket box, what does that look like? Yes, it does. No, we got one in here. Didn't we have one in here?
We use those for the timing. Bracket box. Side bracket box, right here.
See how this guy's got these little adjustment screws where you can sink it in or out depending on how deep your sheetrock is. When you install it, the adjustment screw right there, send it around. Good. I'm glad we got that now.
And then a pocket box, we got a picture of them, and then of course our
favorite handy cutting box right here. Ones with the little flappers on the outside, so you can cut the hole in the wall, flap these down, shove it in, screw these screws in. Once they get tied up against the sheetrock, you won't be able to move that in or out. All right? Everybody clear with that? You want to see it again? Send it around? Sure. Send it around. I'd love to.
What kind of wire are we typically going to use inside of these boxes? What type? It used to be up there on the board.
Romex? Yes, sir. Yep. Romex. That's typically what we're going to use on this. I can't think of any other application where with these non-metallic boxes other than if we get into PVC pipe that we're ever gonna see any kind of other wiring. But for device boxes, you're almost typically always going to see Romex. So, you can use no. Typically, when you're doing a coax, you're just going to do a single gang. Most often that I've ever done is a lot of times you'll have a outlet phone combination. So you'll take your coax and a Cat 5 right into each one of these boxes wherever, like when you lay out your living room or kitchen. Kitchen typically sometimes has a cable outlet. Living rooms for sure. Bedrooms even have a combination. But yeah, on that deal, what I typically do on there, so the wires don't get messed up, is that I'll just pop the holes through both sides of these to where you can run the wire through the whole box, and it's just pop that in there. So whenever you're ready to turn on, it's not in here. You can cut and cut the whole off. Just run it clear through. Pretend it's the wire, and it's just run clear through the box like that. So clamp out the bottom of the box. You can just pull that out. Because a lot of times there is no standard on how long those wires need to be when they come out of the box. So, and I like to be able to come, if you're working on an outlet box down here, I like to be able to bring my hands up here. There is a requirement when we are running power wires that they have to be a minimum of how many inches out of the box? 6 inches out of the box. You grab your wires, give them the same length with your hand, and you cut it off right at the end. Okay. Yeah, but there's no requirement on for those, just as long as you can get the stuff back in the box. Okay, moving on. Tell me what kind of box this is. I heard a lot of mumbles. Single gang nail-on box, right. What is this? Can everybody see that? Is it because this is in the way?
Yes.
You're going to have to move so you can see it. Tyler, Travis, what is that one? Travis, that's what.
Screw in the box, I can't see.
Move to where you can see it.
So just a screw in box?
No.
And then nail it.
See that? See that little flap?
Yeah.
See that little screw right there? And the screw right there? Let me kill the light so it's easier to see. And you might have to stand up. This is important. I can guarantee you that you can on the test is to know these. I can guarantee that I already have to test many. Okay? How many gang boxes is this and what kind? Tyler. How many gang boxes is this? What kind? Is it a nail on, a screw in, or a cut in?
Nail.
Huh? Nail. Yes, sir. Kevin. Yes, sir. Jonathan. Say it loud and proud. A little different here, huh? Yes, sir. That's exactly what it is. This one's a little different from this guy down here, but it's still essentially doing the same thing. These little flaps are going to come out, and that's what's going to go up against the sheetrock. As you screw this in, those are going to flatten out. Okay? Prevent that box from coming out. Let's see. Phil. Yes, sir. Reed. Yes, sir. James. Yes, sir. Thank you. Everybody clear on device boxes? Okay. What's a gang mean again? Number of what?
Device.
Thank you, Brandon. Okay. What are these and where do they go? Who remembers? What are they called? What are they called? Romex connector. Romex connector is what these are called. You may want to know that. Not in your book. We talked about it. Yep, you could call them that. You call them wire grommets, but the proper name is Romex connector. And remember that picture that's in our book on page 25, how it has the knockouts in the back? I think you could faintly see one right here. The two-gang box, the black two-gang screw-in box on page 25. Everybody see it? See how it's got the knockout in the back? That's where you use those Romex connectors. Okay? All right. Sealing boxes. No gang signs here. None. We don't have gang and sealing boxes. What are they used for, guys? Corey, what are they used for?
Lights.
Lights. Where at?
Ceiling.
Ceiling, sometimes the wall too. Sometimes if you've got a vanity that requires a round box, you can see it up on the wall too, above the ground. Typically, those are either round or those could also be light boxes too. Just like that. So what do we have here? What kind of box do we have here? Levi.
Screw it up.
A round screw-in box. Yep, round sealing box. Round screw-in sealing box. Okay. Why are they so different? What's different with this one than is with this one? And this one here and this one here. Clearly, there's something different there that involves the screws. These screws right here are significantly smaller than these screws, right? Whoops. I hate it when I do that. This box right here is designed to have a big, fat, heavy fan hanging on it. That's why it's got the big, thick screws and why it has the spot for the adapter to go through the center. So right here, these screws are going to be removed, they're going to be pulled out, and we're going to use those to go in this hole and this hole, and screw up into the rafters. So we can kind of big heavy damn fan. Big heavy fan. Here's another one. This is a what kind of nail on or screw on for that guy? Nail on, yes sir. And that one is very similar to this, and this is going to be set up for that big heavy fan. Big heavy fan. It's got 2 separate nails on there, so we can hold a little bit more weight. One difference I will want you guys to notice about these. Let me put the line out here real quick. This is a cut-in. I should bring those down. Sorry about that. Something on hard with it. Okay, this is a cut-in, but what I'm trying to illustrate here in the bottom of these, like well, this one probably, and I can't see in that one, maybe not that one, but for sure this guy right here, we have these little brackets in here. What do you suppose those are for? Once we punch a hole in these fiberglass boxes, who's got a screwdriver out? We'll punch a hole in it. Anybody? Nobody? I can use this. You got it? Okay. So right there, you can see with the hole punch in that one, that, boy, if we shove Romex in there, there's not really to keep that thing from moving, right? No. Whereas on these, if we punch this guy down, we can tell that if the Romex tries to pull out, or somebody pulling on it's going to get bound up on that little flap, right? These little things inside of here. These are the clamps to prevent the Romex from coming out. Okay, everybody see the clamp? Yeah, once you get your Romex stuck in there, hopefully you don't need another one, but if you do, you're supposed to reach in with the screwdriver and tighten that clamp down so the Romex can't pull out. So whenever you're doing this, make sure that when you shove your wires in here, you have a little bit of the sheet still inside of the box to where you're not bringing this clamp down right on top of your wires because you can actually short out. Actually, if you get this tight enough, you can short out the hot and the neutral right through this clamp. Keep that in mind. That's what those these are around. They're around. I mean, it just depends. Depends on what your contractor gets, what your boss gets. If you get the screen deal on the fiberglass ones, maybe install them all over again. Install just regular plastic ones. But it is important for you to remember when you are experiencing that. See, here's a great difference right there. You've got this one's got flat, and this one doesn't. Okay. Well, the little flaps can prevent your lumber from coming out. Whereas this you have to put the clamp on. So. Okay. Who remembers what this thing is for? Yeah, that's what this is. It's meant to be able to span between 2 rafters, so if you need to center it right up in the room somehow, you can adjust it side to side between the rafters. Okay? All right.
Everybody square with ceiling boxes? Everybody square with a square head? Okay, hope not. So 4 square box. Where are we going to see one of these? I think maybe where are we at? We talked about,
let's see, device boxes. We talked about screw-in boxes. Side bracket box. We talked about him. Has he made it all the way around? The side bracket box. You got it? Okay. Box.
Let me see. I thought I added a pocket box in here. Maybe not. Nope. I can honestly say
I've never seen a pocket box. So. There's something we can read about it. I definitely would know that the one that has the little cubby hole on the offhand side there is probably going to be important for me to remember that is a pocket box. We talked a little bit about him. Okay. Round bar hanger box. Got him. Ceiling fan boxes. Those are a couple of nice little side pictures of those devils for us.
4 square boxes and mud rings. So if we need to mount, this is going to be in a situation where we need to have a lot of wires because,
okay, we're going to put one gang We're just going to pretend that this is our mothering for now. It's simple. We're going to use, and we're going to pretend this is a 4-square non-metallic nail on like that. How can you tell the difference between this and that? First of all,
Does that have any devices?
right, it does. It does. All it has is these 2 screws on the outside. One of those looks like they're made for. Yep, mothering. Yes, sir. So let's just use this as a little pretend action. This box is quite a little bit bigger than this box, right? If we need to have a whole buttload of wires inside of this box right here, we could get one of these and we could add a mothering on it, and then we could use this as not only a device box but as a Johnson box as well. Okay. So we can put our mothering on here and still have this whole amount of wire space in the back here to be able to use the makeup. So now those device boxes, motherings, can be mounted either up and down to have that same way, or they can be mounted sideways to have it this way. Like say for instance in a backsplash in your kitchen. Typically, sometimes you'll see those outlets mounted sideways. And this is a great spot to use something like that because it seems like the kitchens always have a lot of stuff going on because they've got so many required circuits. So.
Okay. Yep. Is there more inside area? Yes, sir, there is.
We can tell just by looking at this regular device box, and by looking at it, we can tell this has got 22.5 cubic inches, and this has got 32. So clearly we have more space to make up wires inside of here.
All right. Box extender. Why would we ever use one of these?
Here, I'll set this guy around so you can put your hand on it. Oh, right there's why. Right there's why. Sometimes when we put in our boxes in the wall, we're not always 100% sure what the finish is going to be. For example, this looks to be like it's either a kitchen or a bathroom. I'm going to assume it's a bathroom. But when they put this box in, this isn't probably, maybe like this, probably like a commercial bathroom because it's a metal box. Look at that though. See that wire coming in the back there with nothing connecting it? Or maybe that is a little Romex connector in the back. Tough to say. Anyway, that's not the point. The point is we don't know what the wall finish is going to be all the time. Especially in kitchens or bathrooms. We could find a spot where we get this thing here, and we got 1/4 inch to 3/4 inch worth of extra space between the actual box and the device. So we stick our device in there, and it's still that far away from our box. The device is that far away from our box. We have all of that spot in there that we could potentially arc the screws onto something, like example, arc the screws in that device right onto that metal. Sometimes, you know. That's why we use one of those, is that if our wall finish is a little bit too long or too deep for where we put our box, we can throw those in. I can probably count the number of times that I've used this device or a box extender for a non-metallic box on one hand. Okay, not a real high use, but it's, you know, in a certain situation, it might be just what the doctor ordered. Okay. Especially once you get a trim out inspection and the inspector comes walking through as you're putting that stuff in and he notices what you're doing and he says, hey, what do you think you got going on here with that 1/2 inch worth of space between the box and your wall finish there? Also, as I want to point out too, so part of what our intention for our devices is, and I should grab one, is when you stick this guy in here, look how much further out from the top of this sticks from the actual box. This is also designed to go up against the finish of the wall to prevent the outlet itself from sticking back into the wall. Right? So the outlet's got the 2 little ears on the top. Like right here, he's got these 2 little ears up here, but we got this kind of walled out here, this box walled out here. If we fill this in here, we got an extra shoot 3/8 of an inch on the top and the bottom for us to be able to mount that outlet up to, and it's going to have a nice solid base and not be able to push back through. Because I've seen it where we haven't used one of these and we put the outlet in there and you tighten the screws down inside of the thing, but it just bends those little ears in, and your outlet keeps going in up to the box, and then you got, when you go to put your cover on, you got a 3/8 inch gap between your cover and where your actual device is. So. Okay. Okay, moving on. Talked about cut-in boxes before on the next page there, 31. Don't need to beat a dead horse. Pay attention to the picture. If you see a little flap or something that's not really designed to have a nail or a screw in it, it's got the little flapper on the side or on the top or the bottom, you may have a cut-in box on your hand. So keep your eye out for that. So here we have our FS and our weatherproof box. I think that's the next stuff in it. Box extenders and then weatherproof boxes. Here I have a picture on the, let's see, right here. How many gang is this? This is where we're going to talk about the outside stuff. And we're going to run some PVC pipe into here. That's what we're going to use to wire this guy up with. Like you'll see this on like a temporary maybe, or outdoor, yep, single gang, outdoor outlet somewhere on just like maybe a post. When we got this going on, and this is also part of our chapter here, if we're deciding we're going to put an outlet out on a post somewhere outside, and we decide, okay, well, we're just going to use this plastic box, we also got to have this deal here. Who remembers what this is called? Yep, GFCI, but the cover is what I'm talking about, and it's called an in-use cover. In-use cover right here. And that's got to be mounted on the outside if we're planning on using that for an outlet. I think you may even need to do those for switches too. If you want to just have an outdoor switch somewhere. Pretty sure. It might not be as big and bulbous because you only need to just flip the switch on and off. But okay, what kind of gang do we have? How many gang boxes do we have over here? 2 gang. Yep. It's got spot for 2 different devices. Okay, I don't think I have one of those.
This is kind of close to it, but it's not. It's metallic. It's pretty close. It's got the threads here, whereas these guys will just have no threads. You can just shove the PVC right in there and glue it up. So that's very similar to those.
It's more visual. Okay. What time does this class get over? So like now? 9:45? No. 11? 11 what? 10:40. Is that it? 10:40. So we still got over an hour left then, huh? That's okay. That's all right. I'll keep talking. Floor box. I don't have an example of one of these either. They're kind of big and a little bit hard to put in a tiny box. But here is actually what we're going to see the finish of a floor box look like. Okay? There's the finish. You've probably seen those, and if you go into like an office building, those are pretty typically around. We may maybe even have some upstairs. Yeah. Yep. You can see these sometimes like in a concrete floor. You'll see those. But those obviously have to be put in before the concrete is poured. Obviously, right? Unless you want to cut up some concrete. Let's see what it has to say about them. Junction or pull box. Let's talk about him real quick. Just a non-metallic junction boxes can be mounted outdoors in wet locations with the appropriate ratings. They're used to splice components outside. There is a question on your test about an outside junction box. So just be familiar with that, familiar with the picture, and we can talk a little bit more about it when we review. But floor boxes provide Enclosure for receptacles and concrete floors. Yep. They're available in multiple different depths, sizes, shapes. You can see there's square ones too. This is just a round one. This is the example that they had for us. So, yep, floor boxes. Okay. Any questions on floor boxes? One important note too is that they do have dividers available to divide your outlet voltage with your communications voltage. It gets real fun when you get to cut these in a concrete floor. I have done that before with a big old core drill. Put this diameter a hole in, shove that guy up in there. Real fun stuff. Okay, communications for low voltage boxes and rings.
How come we're allowed to have no backs in the box on this particular cut-in?
That right there is a cut-in low voltage communication box. Why can we get away with that? Yep, there's not really a hazard there. We don't need to keep that stuff contained inside a box. So there's not really anything that's going to hurt anybody. This is an important thing right here. We can see that this could be very similar to what we just saw in that floor box about how we bring our outlet in on this side and our communications in on here. We just throw that divider in there to prevent any sort of inductive pickup on our communications cable. A lot of times you get that stuff on when you have a computer. There's a lot of induced voltages that can be picked up from your communications. If you have a computer plugged in here, anything that has a high-speed switching function will put a little notch on an AC wave, and that divider is in there to prevent those two from picking each other up, for the communication picking that up. Okay. Surface mounted box. There they are. All right. I don't know if we need to kill those too much. What is anybody? Let's see. Anybody done any work in here with what's called the wire molding? Yep. That's where you would find a surface mounted box. But usually, most of the time, with wire mold, it's kind of so this is going to be looking at the end of it. They found about 10-foot chunks pieces. So it consists of two pieces. It consists of back, kind of like a bin rail, and then it's got a little cover that's coming out over like this that hooks in. That's looking at it from the end. And then looking at it from straight on, it's kind of got a little raise in the center. But anyways, this is meant to be surface mount, and you run your wires in this space here. This has got holes in it. Everybody knows what's in there, right? No? I don't know. This is the ground next door. This is DIN RAM. DIN RAM, right? Yep, so we got a lot of devices and stuff like this on in our border controls and stuff. But anyways, wire mold is going to be a little bit smaller version of this, and so it's going to have similar holes in the back where you can mount and just a plate that goes over the top. And the tank, if you look, yeah, maybe not. You can't see it really on there. But a lot of times these have just a little notch for where you can plant this right inside the box. Right where inside the box. Not gonna beat that. They'll have instructions on how to install that stuff if you ever get to be involved with it. So. Siding box.
Siding box. Here's a couple of examples of siding boxes. Nothing real tough and difficult there, other than just remember that when you're talking about outside of your house and you want to have a nice something to mount your devices to, you can either have a box that is cut into the siding, like here, or this one right here, we can just barely see, it has a little notch right there, right where that, it kind of confusing when it's blown up, but there's a little notch right there that as they push this back up against the siding, that notch is going to match right up with the coordination in that siding. And we can mount right to the exterior of the siding there. Probably not a super great thing, especially if you're going to hang a huge light on there to be mounting to the siding, unless you go through and get back into the actual wood behind it. Keep that in mind. It could really cause some problems for a homeowner when their light falls off if you just tacked it to the siding. These are not a lot of fun to replace if they get damaged. I'll tell you that from personal experience. They're tough to get the siding pried back and get your siding box replaced. My dog chewed mine up on my last house. Not fun. Best to do those when they're installing the siding. So.
Okay. Is there anything really important that we use? Siding blocks are available with built-in in-use covers too.
As we can see here, this is sunk in quite a bit, so the in-use cover is built in. That's, as long as it's approved and listed and labeled, you go ahead and find to use a nice thin one instead of one of those big bubble ones. So, and I think, let's see, in-use weatherproof cover, we talked about him. The last thing we really need to talk about is the meter socket siding block. So this is going to be used for when you actually mount. I think that might be the end of the slideshow. Yep. This last page on page 40 here, this is going to be used when mounting the meter to your actual vinyl siding. Okay. Most of the time when you're doing service equipment on a house, you don't really give a damn about putting the meter socket siding block up. You just mount stuff. And that's just the way it is. Most of the time your service is going to be located on a spot where it's not in view of the public. So, get a solid anchor. So, I've never seen one of those used, but they are available in various sizes according to our book. Okay, so that's pretty much all we have to talk about in this chapter. Two important things to take away. Code 314. You guys will be loving 314 next semester. Okay, it's got a lot of great information. We don't need to beat it up right now because all we're doing is learning about the actual devices. But once we start learning about the requirements and stuff, 314 is going to be a great reference, and it wouldn't hurt you guys to start getting familiar with it. Let's talk about the assignment that I want to have done, and you guys are welcome to start working on that right now. You may even be able to get it knocked out, but I'll pull it up here for us. So end of show. This homework assignment I kind of just came up with in hopes to be able to get you guys more grades in here than just tests. Because obviously we had some trouble with the test, and if this whole class, if looking in the syllabus that was built, that's my effort to kind of try to help you guys to be able to spread your points out a little bit. And all right, so faculty, we're in 135. So we are officially going to have a test on these boxes on Wednesday next week. Okay, we can spend a little time reviewing again, but we are going to have a test. Coursework, Unit 2 homework. Okay, I would love to be able for you guys who need these points to bring your grade up to have it due on Friday. I have to get these 4-week grades in on Friday, and although these aren't going to do anything for scholarships or anything, you may start to hear a little bit more from our student success coaches if we have some trouble. Right now I have it set for due before the next time we meet, which is next week, 2/8. Would it benefit you guys for your grades to be able to have it due before Friday? It's only worth 25 points, but if you're on the edge of an F and a D, it may save you. It may save you. So if you guys can get this done, actually, let's talk about it real quick. So one important thing for you guys to do when we're moving into this, when I'm starting to assign these, is look for the instructions. Right now, what I'm wanting pictures of device boxes. So you're going to take a picture with your phone, you're going to upload it to your computer, and then you're going to put it on a document, and I'll show you an example. Add them to a Word document and explain how many gang box devices are doing in each. I also want one picture of a ceiling box and one wall-mounted light box, also uploaded to your document. I want to know how each light is being controlled, either a 3-way or a single pole, etc. Points will be awarded when on requirements met and effort put into the document. Okay, so if you just say 3 gang box, 3 single pole switch, you're going to get it for getting it done, but you're not going to get the full amount that I'm going to award. Okay, each one of these is going to be worth 5 points. This is a 25-point assignment. Here's my example. This example is available to you guys to reference to. It took me about 5 minutes to write this up. Okay, so it's not going to be a huge amount of time that you're going to have to spend with this, but I do expect this to be done. So here's the picture that I took of a 4-gang switch box that controls the lighting in my dining room and kitchen. How many gang switch box is this? 4. I didn't put that in here. I should have. The first switch controls the garbage disposal. I can tell that by looking at it because what do we see here? It might be tough to see, but what does this say right above this switch? It says off. It's probably tough for you guys to see. But any switch that has an on and an off on it is going to be a single pole switch. They're going to be on in the up position or it's going to be off in the down position. Now, the first switch controls the garbage disposal, so that's obviously not going to be on the disposal is, or the garbage disposal is. So we reach over and we turn that guy on, and then we turn it right off. Okay. The second switch from the left controls the chandelier above my. This is a 3-way or a 4-way because there's no on or off on it. Controls the chandelier above my table. It's a 3-way switch that can be turned off by the back door as well. So I have a door going right off the side of my dining room. Okay. The third switch controls the can lights in the kitchen. The fourth switch controls the under cabinet lights. The last 2 are also single pole switches. They can be single gang, they can be double gang, or they can be 4 gang, but they cannot all be single gang outlets. Okay, you'll get the point. You won't get the effort part of this. So 3 of these, one ceiling light and 1 light up that's mounted on the wall. Each one of you should have a vanity light in your bathrooms. If not, I bet you can find one around the school. Okay, this is what your assignment is.
assignments to get in this time. So that instruction list that I put on there that we just looked at is on the assignment. So if you get over the assignment and you're like, oh, I forgot what I need to do, all of that information is right there for you.
Friday at class time, so you have until 1 o'clock. Oh, there you are. Okay. You gonna work on this, or you want to start on the test?